No matter what technology or framework we're using, our goal is always to start with a request and use that to create a response. Everything in between those two steps will be different based on your tech or framework. In our app, and in almost every framework, two things that are going to be between the request and the response are the route and the controller. In this case, you can see our homepage has a route, our function is a controller, and our controller returns a response object. And we have the same thing down here with the other page. It has a route, a controller, and that returns a response. So what we're going to look at is how that all works. Who actually runs the router? Who calls the controller? How do events work in between the request-response flow? But before we dive into that, what we're going to do first is create an event listener and hook into that process. Then we'll be able to play with that event listener as we dive into the core of things. I'm going to open up the profiler and go to the timeline. This is going to be our guide to this whole process. This shows everything that happens between the request and the response. Even if you don't understand what's happening yet, after we go through everything, this is going to be a lot more interesting. You can already see where our controller is called, and under the controller, you can see the twig template and even some doctrine calls being made. Before and after that, you notice a lot of those things end in the word listener. That's because in my app bundle, I'll create a new directory called event listener and a new class. Inside this event listener, we're going to read the user agent header off the request and do some things with that. So I'll call this user agent subscriber. If you want to hook into Symfony, there are two ways to do it, with a listener or a subscriber. They're actually exactly the same thing. The only difference is where you configure which event you want to listen to. I'm going to create a subscriber here because it's a little more flexible. So user agent subscriber needs to implement event subscriber interface. Notice that added the use statement up there. And we're going to need to implement one method, which is get subscribed events. What this is going to return is a simple array that says, hey, apparently there's some event whose name is kernel.request. We don't necessarily know why it's called that or what it does yet. But when that event happens, I want Symfony to call this onKernelRequest function, which we're going to put inside this class. For now, let's just put a die it works. Cool, the event subscriber is ready to go. No, Symfony doesn't automatically know this class is here or automatically scan the codebase. So to get Symfony to know that there's a new user event subscriber that wants to listen on the kernel.request event, we're going to need to register this as a service. So I'm going into app config services.yml, and I'll clear out the comments. And we'll give it a short but descriptive name, user agent subscriber. The name of the service doesn't really matter in this case. There are no arguments yet, so I'll just put an empty array. Now, in order for Symfony to know this is an event subscriber, we'll use something called a tag and set its name to kernel.eventSubscriber. That tag is called a dependency injection tag, which is really awesome, really advanced, and really fun to work with inside of Symfony. And we're going to talk about it in a different part of this series. With just this configuration, Symfony will boot, it'll know about our subscriber, and when that kernel.request event happens, it should call our function. Sweet! Now inside of onKernelRequest, let's do some real work. For now, I want to log a message. I'm going to need the logger, so I'll add a constructor and even type in the argument with the PSR logger interface. And I'll use a little PHP-Storm shortcut to create and set that property for me. Now in our function, we'll log a very important message. And of course, this isn't going to work unless we go back to services.yml and tell Symfony, hey, we need the @logger service. Cool. Let's refresh. It works, and if we click into the profiler, one of the tabs is called Logs, and under Info, we can see the message. Whenever you listen to any event, whether it's one of Symfony's core events or it's an event from a third-party bundle you installed, your function is passed an event argument. So we'll add $event. The only trick is that you don't automatically know what type of object that is, because every event you listen to is going to pass you a different type of event object. But no worries, I'm going to use the new dump function from Symfony 2.6. Let's go back a few pages, refresh, and the dump function prints that out right in the web debug toolbar. And we can see it's dumping a getResponseEvent object. So that's awesome. Now we know what type of object is being passed to us, and that's important because every event object will have different methods and different information on it. Let's type hint the argument. Notice I'm using PHP Storm, so that added a nice use statement at the top. Don't forget that. What I want to do is get the user agent header and print that out in a log message. Fortunately, this getResponse object gives us access to the request object. And again, every event you listen to will give you a different event object, and every event object will have different methods and information on it. It just happens to be that this one has a getRequest method, which is really handy for what we want to do. Now, I'll just read the user agent off the headers and log a message. Let's try it. I'll get back into the profiler, then go to the logs. And it's working perfectly. The first important thing is that we instantiate the app kernel, which is the same app kernel you have in your app directory where you register your bundles. We'll talk more about this class in another part of this series. We'll also talk about this load class cache function, but for now, comment it out. It can get in the way if you're debugging core classes. And also, just know that the app kernel is the heart of your app. The first real important thing I want to look at is the request : create from globals. We all know that we start with the request. And hey, here's where the request is born. Request is just a simple object that holds data. And this creates a new one that's populated from the superglobal variables. Those things like $$_get, $$_post, $$_server. In fact, if we look inside, it's creating an instance of itself populated from those exact variables. Now that we're starting with the request object, the next line is the most important line inside of Symfony, the kernel arrow handle method. What's really cool about this is that you see that the handle method has input request, output response. And that is actually amazing. It means that everything that our application is, the routing, the controller, the services, all of that stuff happens inside of this handle function, inside of that kernel handle method. The kernel class is our app kernel. If I hold Command and click into the handle function, it's going to take us not into app kernel, but its parent class, kernel. This class is something we're going to talk about in a different part of this series. Ignore for now, because it offloads the work to something called HTTP kernel handle. I'll use a shortcut in my editor to open HTTP kernel. In P, we're looking for that handle function. Because effectively, when we call handle in app_dev.php, it's being passed to this handle function. You can see the request argument. Awesome! Now what is handle actually doing? So far, not much. The important thing to take away here is that there's a try-catch block. This means that if you throw an exception from anywhere inside your application, like a controller or a service, it's going to get caught by this block. And when that happens, you'll get passed to that handle exception function, which is what tries to figure out what response to send back to the user when there's an error. That's something we'll talk about later. The real guts of this are in a function called handle raw, and this lives just a little bit further down inside this same class. We're going to walk through every line of this function. You can see that it's not that long, and what's really amazing is that handle raw is the Symfony framework. This is the dark core guts of it. So let's start working through this. The first thing we have is this request stack push. This is going to make more sense a few lessons from now. But as we saw before, Symfony has the ability to process many requests at a time via something called sub-requests. The request stack is just an object that keeps track of which request is being worked on right now. We'll talk more about that idea later. For now, just ignore it. For us, the first interesting thing that happens inside of this function is that it creates a getResponse event object. Despite its name, that doesn't do anything. That just creates a new object with some data in it. Some of you may already be saying, hold on, that class sounds familiar. If we look inside our user agent subscriber, you remember that it was passed a getResponse event object. And this is where that object was created. It then goes to a dispatcher, which dispatches our first event. That kernel events : request is just a constant that means kernel.request. So ultimately, this line causes the dispatcher to loop over and call all of the functions that are listening to the kernel.request event. And it passes each that getResponse event object. And because of this nice constant, we can actually use it inside our subscriber. So I'll change this to kernel events : request and add a comment so I don't forget what this really means. So when every listener like this is called, it's passed that getResponse event that's created in HTTP kernel. There are a lot of listeners to kernel.request, but there's only one that's mission critical to how the Symfony framework works. Let's go back to the browser, refresh the page, and click into the profiler. Back on the Events tab, we can see all of the functions that are called when this event is dispatched. The one that's important for understanding how the framework works is that router listener one that we can see in the middle. So let's go back and open up router listener in PHP Storm. If you ever see a class in the app/cache directory like this, ignore that. You want the one that's really inside of the vendor directory. If you look at the bottom, this is an event subscriber, just like our event subscriber. And you can see it listens on kernel.request, and its onKernelRequest method is called. As the name of this class sounds, this is what's responsible for actually executing your routing. And remember, we can write routing in a lot of different ways, in YAML files, in annotation like in our app, or other formats. But ultimately, if you run router::debug, you get a list of all of the routes. Most of these are internal debugging routes, but our two are at the bottom. My question is, what's the end result of running the router? For example, if we're on the home page, does it return the string dinosaur_list? Something else? If we trace down in the function between lines 124 and 128, that's where the router is actually being run. You can see that there's an if statement, but that's not really important. Both sides do the same thing. They figure out which route matched. And you can see that it returns some parameters variable. What's in that? Is that the name of the route or something else? Let's use the dump function to find out. This runs on every request, so let's go back, refresh, and there it is. When the router matches a route, what it returns is an array of information about that route. And the most important piece of information is what controller to execute, which it puts on an _controller key. Because, remember, our flow is always request, routing points to a controller, and the controller is where we create and return the response. The format of the controller is the class name, : then the method name. If you open up the dinosaur controller, this all comes from here. When you use annotation routing, it's smart enough to create a route where the _controller is set to whatever method is below it. If you've used YAML routes before, it's even more interesting. I'll open up my app config routing.yaml file. At the bottom, in comments, I prepared a route that's identical to the one we're building in annotations. When you use YAML routing, to point to the controller, you have a defaults key, and below that, you have an _controller that uses a 3-part syntax to point to the dinosaur controller and index action. So just to prove this is the same, I'm going to load only that route. And when we refresh, the routing parameters are exactly the same. Let's comment that back out. Now let's go to a different page, /dinosaurs/22. And what we see now is that in addition to _controller, we have the ID value from the route. This shows that the end result of the routing layer is an array that has the _controller key plus any wildcards that are in your URL. It also gives you the _route in case you need it, but that's not important. And if you want to get really crazy, you can even pass extra variables via the defaults of a route, and those show up here as well. One more cool thing. If you look in the cache directory, you'll see a file called app.dev.urlmatcher.php. This is the end result of parsing through all of your routes, whether they're written in annotation, YAML, or some other format. So when we see this matcher match in router listener, that's actually calling the match function you see inside of that cached class. Symfony is smart enough to parse all of your routes, then generate this big, crazy regex if statement matching algorithm thing. If we scroll to the bottom, you'll see our dinosaur pages. Okay, this isn't important to understand, I just think it's cool. So let's get rid of the dump and trace through what happens next. If you look below, you'll see that it takes that parameters array, which has _controller and ID, and puts it into a request arrow attributes property. Symfony's request object has a bunch of these public properties. I'll open up the components documentation for the HTTP Foundation component because it talks about this. Every public property except one has a real-world equivalent. For example, if you want to get the query parameters, you say request arrow query arrow get. If you want to get the cookies, it's request arrow cookies arrow get. For the headers, it's request arrow headers arrow get. All of these are a way to get information that comes from the original HTTP request message. The one weird guy is request arrow attributes. It has no real-world equivalent. It's just a place for you to store application-specific information about the request, and route info is exactly that. Putting information onto the request arrow attributes property doesn't actually do anything. It's just a place to store data. It's not triggering any other systems or functions. We're just modifying the request object, and that's it for the router listener. Let's close this up and go back to HTTP kernel. At this point, the only thing we've done is dispatch the kernel.request event, and the only listener that's really important is the router listener. And of course, all it did was modify the request arrow attributes, so not a lot has happened yet. If we follow this down, there's a really interesting if statement. If the event has a response, and I'll show you what that means, it exits immediately before calling the controller or doing anything else. We'll look at that filter response method later, but it doesn't do anything mission critical. This means that any listener to kernel.request can just create a response object and say, I'm done. For example, if you had a maintenance mode, you could create a listener, check some flag to see if you're in maintenance mode, and return a response immediately that says, we're fixing some things. Let's try this. In user agent subscriber, I'll create a new response object. Make sure you use the one from the HTTP Foundation component. PHPStorm did just add a use statement for me up on line 7. And we'll say, come back later. The getResponse event object we're passed has an event setResponse method on it. Remember, every event passes a different object, and this one happens to have this setResponse method on it. We'll make things more interesting and put this in a block so it only randomly sets the response. If we go and refresh now, the page works fine. Refresh again and again. Okay, mine is being stubborn. There we go. So now you can see that as soon as the response is set, it stops entirely. I'll leave this code in there, but let's comment it out so it doesn't ruin our project. Perfect. In reality, there's no listener that's setting the response for us like this. So our next job will be to figure out which controller function to call to create the response. Okay guys, we made it through the routing layer. Looking back, all it really did was add an array with a few items to the request attributes property. The really important thing it added is _controller. And that's a string that points to the class and function of our controller. But it also added the value of each wildcard that's in whatever route was matched. Now Symfony needs to figure out which controller to execute for this request. Wait a second, isn't that exactly what the _controller value is? Yes! Wait, no, not exactly. That's a string, and while it looks like a function, it's not technically a callable thing yet. You'll see what I mean. Symfony figures out which controller function to call for the request by using something called the controller resolver and calling getController on it. Ready to go one step deeper into the core? Great. Let's open this class up. Oh, and there are actually two classes called controller resolver, one inside the HTTP kernel component and the other inside framework bundle. Open both of them. The one in framework bundle extends the other. See, base controller resolver is the one that lives in the component. Most functions we'll look at are in the parent class, but one is overridden in the child class. The getController function lives in the HTTP kernel controller resolver, so let's find it. A controller is any callable function, and Symfony's HTTP kernel doesn't care if that's an anonymous function or a method inside of an object. A lot of code that you'll see here is to support this very important fact. Okay, this is cool. What's the first thing this function does? It goes out to the request attributes and looks for that _controller key. Aha! So why do we use _controller in our YAML routes? And why do annotation routes create a route with _controller behind the scenes? Simply because this line looks for that key. And if it doesn't find one, this function doesn't do anything. It panics and exits immediately. Most of the rest of the code is basically trying to figure out, hey, is the _controller key in the request attributes maybe already a callable function? In our case, it's not, and let's dump it to get a reminder of what it looks like at this point. Go back to the home page, refresh. Our controller is this string, not technically a callable function yet, even though it looks like a function name. A variable is a callable if you can invoke it via the call_user_func function. But in other circumstances, the controller might already be a callable. Silex is a perfect example. There, your controllers are anonymous functions, and behind the scenes, the function is set on the _controller key of the route. So for Silex, _controller is a function, and it would exit earlier in this process. But in the Symfony framework, we don't exit early. Instead, we fall down into the createController function. This is overridden in the child controller resolver, so switch to the one that's in the framework bundle. And there's our function. Ah, this is awesome again! Look at the first part. It looks to see if your controller already has a : syntax in the middle of it. And if you don't, you fall into this first block. Remember that app bundle : default : index syntax you use in YAML routing? That's handled here. The this arrow parser you see on line 60 is responsible for transforming that 3-part syntax into the longer class name : method name that ours already has. The block below this, around line 63, handles the service syntax. So if you do decide to register your controllers as a service, you have a different syntax, and this is the logic that handles that. Ultimately, we fall down to the bottom, and one way or another we end up with the string, which is the class name, : and then the method name. Next, this splits that on the : and a strange list function sets the first part to a controller variable and the second part to a method variable. I'll dump those variables to be totally clear. The list function confuses me sometimes, and the real key is what these two new variables are set to. At this point, it's time to see if we've messed up. Maybe this class doesn't exist, maybe there's a typo somewhere. It gives us a nice error message in that case. Okay, ready? On line 79, you can see the line that actually instantiates your controller object. We knew that it had to happen somewhere because our methods are non-static, and there it is. And because Symfony doesn't know anything about your controller class, one of the rules, unless you register your controllers as a service, is that your controller class can't have any constructor arguments. Because you can see, it just says new class. The next line is really, really important to just about everything you do every day in Symfony. It says, if your controller object implements the container-aware interface, then call controller setContainer and pass it the $container. So if I open up Dinosaur Controller and click to open Symfony's base controller, you'll see that it extends a container-aware class. Let's click to open that. And we see that it implements the container-aware interface. So if our controller extends Symfony's base controller, we automatically implement that interface. Because of that, the controller resolver does call setContainer on our controller class, which is this function here. And what does it do? It just sets that on a protected container property. And this is the reason why in our controller functions, we can say this arrow container arrow get, and then get out whatever service we want. If, for some reason, you didn't want to extend Symfony's base controller, but still wanted access to the container, that would be fine. You would just need to implement that container-aware interface yourself, and then have, maybe, a similar setContainer method that sets it on a container property. Back in Controller Resolver, we now have a controller object, we have the method that's going to be called on it, and it just returns an array with these two things. This is a callable format syntax in PHP. This ultimately goes back to the other controller resolver, and it's returned all the way back to the HTTP kernel handle raw function. Close the framework bundle controller resolver because we're done with it, but leave the other one open. Now, $controller's some callable function. Inside of Symfony, it's going to be an object with a method name, but in Silex, it will be an anonymous function, and it really could be any callable. Okay guys, what's next? Hey, let's dispatch another event. This one is called kernel.controller. And like I keep promising, this one is passed a totally different object called filterControllerEvent. Why would you listen to this event? Well, filterControllerEvent has a getController method on it. So if you needed to do something based on what the controller is, or even change the controller in a listener, maybe to mess with your coworkers, a listener to this can do that. But for understanding the Symfony framework, this is just another hook point. There's no mission-critical listeners to this event, so let's keep moving. We have $controller, so we can call it, right? Whoa, slow down. We don't know what arguments to pass to the controller callable yet. To figure this out, we'll go back to Controller Resolver and do a function called getArguments. Open HTTP kernel's controller resolver back up and scroll down to find this. This entire if statement is just a way to get some information about the arguments to the controller function by using PHP reflection. It needs the if statement because getting that info is different if your controller is an anonymous function, a method on an object, or something else. But ultimately, that info about the arguments is what's passed as the $parameters argument to do getArguments. Let me show you what I mean. Let's dump parameters and put a die. If we look at Dinosaur Controller show action, we have one argument, $ID. The route has curly brace ID, so this is $ID. We all know how those match by name. In fact, we're about to see how that works. So if I go to /dinosaurs/22, you can see that the dumped parameters has just one item in it, And in that reflection parameter object is a name with ID, since this is info about the ID argument. Add a few more arguments like $foo and $bar and refresh. Now we have 3 items and parameters. This one has foo and this one has bar as a name. So it's just metadata about what arguments are on that controller function. In do_get_arguments, the first thing it does is so important and so geeky cool. It goes back to request attributes, that same thing that was populated by the routing. Let's dump this out quickly to remember what's in there. When we refresh, it has _controller and ID from the routing wildcard. It also has a couple of other things that honestly aren't very important. Keep that array in mind. The do_get_arguments function iterates over parameters, the array of info about the arguments to our controller. And the first thing it does is check to see if the name of the parameter, like ID, exists in the attributes array. And if it does, it uses that value for the argument. This is exactly why if we have a curly brace ID inside our route, its value is passed to a $ID argument in the controller. This is why and how that mapping is done by name, because controller resolver says, hey, if I have an ID argument, is there an ID inside the request attributes, which is populated by the routing? And if there is nothing in the attributes that matches up, it goes to the else if, because there's one other case that works. And you've probably seen it while doing form processing. This is when you have an argument type hinted with the request class. In controller resolver, it says if param get class and param get class is instance of the request. The param get class asks if the argument has a type hint. The second part checks to see if the type hint is for Symfony's request class. If it is, the request object is passed to this argument. This is completely special to the request object. It doesn't work with anything else. But guys, it's really pretty if you think about it. Our whole job is to read the request and create the response. So it makes a lot of sense to be able to have the request as an argument to a function that will return the response. Input request, output response. And those are really the only 2 cases that work. The other else if is there just to see if maybe you have an optional argument, and if you do, it uses the default value instead of blowing up. If all else fails, it tries to get a nice exception message to say, hey dude, you have an argument and I don't know what to pass to it. For example, if I had a bar argument that's not optional, there's no curly brace bar on the route, so we should see the controller requires that you provide a value error. And we do. That's actually where that error comes from. If we get rid of that, it should pass the request to one argument, and it should be okay with foo being optional. When we refresh, it's happy. Now that we're done, the array of argument values is passed all the way back to HTTP kernel. And now we're dangerous. We have the controller callable and the arguments to pass to it. Okay, any ideas on what we should do next? Yep, we finally call the controller. So on line 145, that's literally where your controller is executed, and it passes it all of the arguments. And what do Symfony controllers always return? They always return a response object, and we also see that on line 145. Unless they don't return a response, and that's what we're going to talk about next. We've journeyed far, brave traveler. And now that Symfony has called our controller, let's start our adventure home. Our controller is returning a response object. We're calling render, and that's a shortcut that renders the template and puts it inside of a response object. And even though I love to say that the one job of your controller is to create and return a response, it's a lie. You can return whatever you want from a controller. And if you don't return a response, what does Symfony do? It dispatches another event. This time it's called kernel.view. The purpose of a listener to this event is to save Symfony. It really needs a response object, and if the controller didn't give it to us, it calls each listener to this event and says, hey, here's what the controller did return. Can you please somehow transform this into a real response and save the day? Okay, but what's the use case for this? In a true MVC framework, the controller is just supposed to return some data, not a response. For example, imagine if our dinosaur controller show action just returned a dinosaur object, instead of the HTML response. And then imagine we added a listener on this event that saw that dinosaur object, rendered the template, and created the response for us. The result would be the same, but would be splitting things into two pieces. The fetching and preparation of the data would happen in the controller. The creation of a representation of that data would happen in the listener. To some of you, this might sound ridiculous. I mean, why do all this extra work? One real use case is for APIs. Imagine the endpoints of your API need to be able to return both HTML or JSON depending on the accept header sent by the client. In your controller, instead of having a big if statement for the two different formats, it just returns data. Then, you'd have a listener on kernel.view that first checks to see if the user wants HTML or JSON. If the user wants HTML, it would render the template. If it wants JSON, it would take that dinosaur object and turn it into JSON. The FOS REST bundle has something that does exactly this. You can return data from your controller, and it has a listener on the kernel.view event that transforms that data into whatever response is asked for. In normal Symfony, there's nothing important that listens to this event. But when it's dispatched, it's hoping that one of those listeners will be able to set the response on the event object. If we still don't have a response, that's when you get the error that the controller must return a response. Oh, and this is one of my favorite parts of the code. If the response is actually null, it says, hey, maybe you forgot to add a return statement somewhere in your controller? Yep, I've seen that error a few times in my days. Since our controller is returning a response, if we go back and look at the Events tab in the profiler, we'll see that there's no kernel.view in the list at the top. But below, there's a not called listeners section, and there is one listener to kernel.view, which comes from the Sensio Framework Extra bundle that's not being executed. Our controller returns a response, so we skip the entire kernel.view block and go straight down to the filter response call. This function showed up in one other place further up. If one of our kernel.request listeners sets the response also goes through this function. So no matter how we create the response, filter response is called. What does it do? Come on, you should be able to guess by now. It dispatches yet another event, and this time it's called kernel.response. What's awesome about kernel.response? Well, listeners to it have access to the response object by calling getResponse on that filter response event object. So if you want to modify the response, like adding a header, this is your event. In fact, the web debug toolbar works via a listener on this event. When we load up a page, the web debug toolbar shows up at the bottom. This works because at the bottom of the HTML source, there's a bunch of JavaScript that makes an AJAX request that loads it. But how did that JavaScript get there? The answer, with a listener on the kernel.response event. That listener injects the extra JavaScript into the HTML code of our page when we're in development mode. So all filter response does is give us another hook point. It also calls finish request, which is honestly less important. It dispatches another event and removes our request from the request stack. That request stack is an object that keeps track of all the requests we're processing. We'll talk about sub-requests in a second, and then it'll make sense how Symfony can be handling multiple requests at once. After this, the response object is returned all the way back to app_dev.php where we started. We just made it through Symfony's core and came back out alive with the response in hand. What do we do with it? We call send. This sends all the headers with the header function and echoes the content. The absolute last thing that happens is kernel terminate, which is back inside HTTP kernel. Surprise! It dispatches another event called kernel.terminate. Listeners to this event are able to do work after the response has already been sent to the user. In other words, you can do work after your user is already happily seeing the page. Crazy, right? So if you have something heavy, like sending an email, you could queue the email to be sent from inside of your controller, but offload the sending to a listener on this event. The user would see the page first, and then the email would be sent. You have to have your web server set up correctly, but Symfony has all of that documented. That's it, guys. There's nothing more to see. Unless something goes wrong. In the not called listeners section, there's one more important event, kernel.exception. Look back at the original handle function that had the try-catch block. You can probably guess what's about to happen. If there was an exception, this calls handle exception. This lives further below and... surprise! It dispatches an event called kernel.exception. The purpose of a listener to this event is to look at the exception object that was thrown and somehow convert that to a response. Because even if the servers are on fire, our user ultimately needs a response. They need to see an illustration showing that our servers are being eaten by gremlins. Some listener needs to create that final response for us. And that's exactly what this code does. After dispatching the event, it checks to see if the event has a response, and gives up if no listeners have helped out. In the real world, when an exception is thrown, like on a 404 page, we see this pretty exception page while we're developing. In the prod environment, we would see an error template. These responses are created by a listener to this event called exception listener. I know, not the most creative name. Anyways, if you want to see how the exception handling works inside Symfony, you can open up this exception listener and trace through some of its code. I won't talk about it now, but it uses a sub request, and that's the next topic. To be really hip, you could register your own event listener and do whatever the heck you want with it, like showing an XKCD comic to random users that come to your 404 page. You know, get creative. Call me crazy, but when we zoom out, I think the request-response flow for Symfony is pretty darn simple. It's basically event, controller, event. Go back and look at the timeline in the profiler, because now it tells a beautiful story. At the top, we see that kernel.request happens first, and everything below its bar are listeners. Then, it figures out which controller we want. That's the controller.get callable part. Cool. Next, it dispatches kernel.controller, and you can see its listeners. After that, the controller is called, and the stuff under that is our work. We can see some doctrine calls we're making, and the time it takes to render the template. After the controller, the kernel.response event is dispatched. It has a few listeners. And there's kernel.terminate. Brilliant. So guys, it's just events, call the controller, then more events. Yep, that's really it. And now that we've journeyed to the core of Symfony's request-response flow, let's bend this to our will to do some crazy custom things. If this were the Matrix, you'd be seeing ones and zeros running across your code. Your Symfony world is now one without rules or controls, without borders or boundaries. Let's prove it. We know that Symfony reads the _controller key in the request attributes and executes that as the controller. This is set by the router listener, but it could be set anywhere. Let's go adventuring. User agent subscriber listens to kernel.request. What if we just replace the _controller key here with something else? Let's do that and set it to an anonymous function. Symfony doesn't see any difference between this function and a traditional controller. To prove it, return a normal response object. When we refresh, would you believe it, that actually works. Comment this line out, just so we don't mess things up. Even within listeners to a single event, there's an order of things. In the Events tab of the profiler, you can see that our listener is the last one that's called by kernel.request. The router listener is executed before us. That means that routing is being run and the _controller key is being set. Later, our listener just replaces it. But even if our listener were run before the router, our little hack would still work. That's because router listener has a special piece of code near the top that checks to see if the _controller key is already set. If it is set somehow, the routing actually never runs. That'll be important in a second when we work with sub-requests. And since our anonymous function is a valid controller, we can still use arguments on it just like normal. So if I go to /dinosaurs/22, which has a curly brace ID in the route, we're allowed to have an ID argument. So this works just fine. All controllers are created equal. Now let's comment that out temporarily, or really more like permanently. Have you ever been in a Twig template and you suddenly need access to a variable you don't have? Open up base.html.twig and let's pretend that we want to render the latest tweets from our Twitter account at the bottom. Since there's no one controller that fuels this template, there's no way for us to pass the latest tweets to this template. When you're in the spot, there are two fixes. First, you could just create a new Twig function and a Twig extension. That's usually the best approach. The second option is with the Twig render function, and that's our gateway to sub-requests. This also lets you cache that chunk of HTML, but we'll talk about that another time. When we use render controller, this lets us execute a totally different controller. Let's render a new controller called _latest_tweets_action in our same controller class. I put the underscore in front of the name just as a reminder to myself that the controller only returns a fragment of HTML, not a full page. I don't really want to bother with Twitter's API right this second, so I'll copy in some fake tweets instead. Now let's render a template and pass those guys in. Yeah, this is only going to return a page fragment, but we still always return a response object from a controller. So that's what we're doing here. Let's create this template, underscore latest tweets.html.twig. I'll just paste some code in that loops over these tweets and puts them in a list, so nothing scary here. The twig render function will call out to this new controller function, get the response, grab its content, then put it all at the bottom of the page. Scroll down. Hey, and there it is! Okay, why is this important to understanding the core? Open up the profiler and go back to the timeline. Okay, it looks normal at first, and we can see where our controller and template are run. But hey, what's that darker bar behind the template? Scroll way down to find a second request called a subrequest. Oh my god! The subrequest is totally independent. It goes through the entire same process we just learned. It executes the kernel.request listeners, it dispatches the kernel.controller event, it calls the underscore latest tweets action controller, and has kernel.response on the end. It really is like we are handling two totally separate request-to-response cycles. Heck, you can even click to see the profiler for just this subrequest. Remember that in user agent subscriber, we're adding isMac to the request attributes, and that means it's available as an argument to any controller. And that's no different with our subrequest controller, since this listener is called for that request too. To prove it, I'm going to add the $isMac argument. Let's pass this into our template and print it out to make sure it's working. When we go back and refresh, we see that on the top it shows that we're on a Mac, and on the bottom, inside the tweets area, hey, we're on a Mac too. Yes, so no surprises. But here's where things get crazy. Go back to user agent subscriber. Let's add an override so it's easier for us to play with this isMac stuff, since I'm pretty permanently using one. If there's a query parameter called notMac that's set to some value like 1, then let's set isMac to false. Back on the browser, when I refresh, I'm still on a Mac. But if I add a $notMac equals 1 to the URL, it goes away. The override correctly makes it look like I'm not on a Mac. Cool. Okay, now scroll down. What? The subrequest still thinks we're on a Mac. Something just short-circuited in the system. But before we fix it, let's dive one level deeper and see how subrequests actually work. To learn how subrequests really work, let's leave this behind for a second and go back to Dinosaur Controller Index Action. I'm going to create a subrequest right here by hand. To do that, just create a request object. Next, set the underscore controller key on its attributes. Set it to @bundle::dinosaur::latest tweets. Then, I'm going to fetch the http_kernel service. Yep, that's the same HTTP kernel object we've been talking about, and it lives right inside the container. Now, let's call the familiar handle function on it. Yep, once again, the exact same handle function we've been studying. Pass it the request object and a subrequest constant as a second argument. I'm going to talk about that constant in a second. Let's think about this. We're already right in the middle of an HTTP kernel handle cycle for the main request. Now we're starting another HTTP kernel handle cycle. And because I'm setting the underscore controller attribute, it'll know which controller to execute. That subrequest is going to go through that whole process and ultimately call latest tweets action. I'm not going to do anything with this response object. I'm just trying to prove a point. If we refresh the browser and click into the timeline, we now have two subrequests. One of them is the one I just created. If you scroll down, you can see that. The other one is coming from the render call inside the template. Okay, let's comment this silliness out. I wanted to show you this because that's exactly what happens inside base.html.twig when we use the render function. It creates a brand new request object, sets the underscore controller key to whatever we have here, then passes it to HTTP kernel handle. Whether you realize it or not, now we know why we're getting the weird isMac behavior in the subrequest. The user agent subscriber, in fact all listeners, are called on both requests. But the second time, the request object is not the real request. It's just some empty-ish request object that has the underscore controller key set on it. It doesn't, for example, have the same query parameters as the main request. That's why the first time user agent subscriber runs, it reads the $not_Mac=1 correctly. But the second time, when this is run for the subrequest, there are no query parameters. This is why our override is failing. Here's the point. When you have a subrequest, you need to not rely on the information from the main request, or master request. That's because the request you're given is not the real request. Internally, Symfony duplicates the main request, so some information remains and some doesn't. That's why reading the user agent header worked in the subrequest. But don't rely on this. Think of the subrequest as a totally independent object. So whenever you read something off the request, you need to ask yourself, do you feel lucky? I mean, you need to make sure you're working with what's called the master request. This means that our user agent subscriber can only do its job properly for the master request. On a subrequest, it shouldn't do anything. So let's add an if statement and use an isMasterRequest method on the event object. If this is not the master request, let's do nothing. Oh, and how does Symfony know if it's handling a master request or a subrequest? That's because of the second argument here. So when you call HTTP kernel handle, we pass in a constant that says, hey, this is a subrequest. This is not a master request. And then your listeners can behave differently if they need to. Okay, refresh. A huge error. This makes sense. User agent subscriber doesn't run on the subrequest. So isMac is missing from its request attributes. And because of that, we can no longer have an isMac controller argument in a subrequest. But wait! I do want to know if the user's on a Mac for my subrequest. So what's the solution? The answer is really simple. Just pass it to the controller. The second argument to the controller function is an array of items that you want to make available as arguments to the subrequest controller. Behind the scenes, these are put onto the attributes of the subrequest. So we can add a userOnMac key and set its value to the true isMac attribute that's stored on the master request. So app.request.attributes.get isMac. Inside of the controller, add a userOnMac argument and pass it into the template. Now when we refresh, we still have the $not_Mac=1, so the Mac message is missing from the master request part at the top. Cool. And if we scroll down, the subrequest also knows we're not on a Mac, because we're passing that information through. When we take off the query parameter, it looks like we're on a Mac up top and on the bottom. Brilliant. The lesson is that you need to be careful not to read outside request information, like query parameters from the URL, from inside a subrequest. This also ties into HTTP caching and ESI, which are some of my favorite topics, and we'll cover those in another screencast. If we follow this rule and you do want to cache this latest tweets fragment, it's going to be super easy. Alright, see you guys next time.